I'm Anil Kumar sharing with you a video on rate of change application. Now with the help of this video, I'll also discuss what is average rate of change and what is instantaneous rate of change and how are these two things linked, right? The question here is, a pebble is dropped from a cliff of height 80 meters. After t seconds, it has fallen a distance of d meters where d of t is equals to 5t square. T is between 0 to 4. First part of the question is find average velocity of the pebble from t equals to 1 to t equals to 3. Part B is find average velocity of the pebble during the time interval t equals to x to t equals to x plus h. You can always pause the video, answer the question, and then look into my suggestions. Now, let's see what is average velocity. Velocity is rate of change of displacement, right? So in this case, distance is given by d of t equals to 5t square. So when we want to find average velocity, let's say, let me write it in short, average velocity, it is equals to, and that too between t1 and t3. That really means rate of change of distance in this interval. So distance at 3 minus, you can always call it a position back position also, right? So t1, I would write 1, okay, divided by 3 minus 1. Is it okay? Now you can get this position by substituting 3 in your equation, right? So that means 5 times 3 square minus 5 times 1 square divided by 3 minus 1, which is 2. Don't forget to write units, right? So this, you can take 5 common, 9 minus 1 is 8, or you can just write 9 times 5 is 45. Use your calculators, 5 over 2, and that is 40 over 2, which is 20, right? Units are meters per second. So that's important. So the average velocity during the interval 1 to 3 is 20 meters per second. Now the second part of this question is find the average velocity of the pebble during the time interval x to t equals to x plus h. So normally we say where h is very, very small as compared to 1. Right? But it's not necessary to have that condition. Anyway, if we put this condition, then average velocity becomes instantaneous velocity. Right, so that is the link between average and instantaneous velocity. So the other point, x value, is just very close to x, h less than, very, very less than 1, 0.001 for example, right? So the 2 points are very close. Average velocity, the secant becomes the tangent and their slope will become the instantaneous velocity. That's the concept here, right? So now let's calculate this using the same formula which we did earlier, right? So we are saying velocity, let me write now in general. So at x plus h, we'll write 5 t plus h whole square minus, I should have written x, I'm sorry, x plus h, and then 5x whole square, is it okay? Divided by x plus h minus x, is it okay? So we have applied the same formula. For average velocity, the formula is, let me write the formula on the top itself. Since we are saying d is our function, so we are saying d of t2 minus d of t1 divided by t2 minus t1. Is it okay? That's the formula which we are using. Okay. So let's expand. It is 5 times x square plus 2xh plus h square minus 5x square over h. Now, if you expand this, 5x square and 5x square cancel. Is it okay? You're left with all this. And from here, I can take h out. So we have 5h, this cancels, right? 5x squared minus 5x squared is 0. So you are left with these two terms. Is it okay? So we are left with 5 times 2xh plus h squared over h, right? So let me rewrite here. So the velocity is, I can take h common. So you have 5h times 2x plus h over h. Now we'll cancel h, right? So you have to factor before cancelling. That's important. So we have 5 times 2x plus h. So that becomes, in general, average velocity between any 2 points, right? And the units will be meters per second. Is that clear to you? Correct? Now, if the question is, find velocity accurate to, let's say, 2 decimal places. In that case, we could take h as 0.01. Do you get an idea? So it says find accurate to 2 decimal places at, let's say, x equals to, let's say, somewhere in between 2 seconds. Is that okay? So let's do this part. So that is an extension to the example. So we'll substitute the value. So the velocity could be now written as 5 times, x is 2 for us. So we'll write 2 times 2, right? Plus, when we say 2 decimal places, we write h as 0.01, 0.01. Is it okay? So what we get here is 2 times 2. This is 2 times 2. Is it okay? So we get 5 times 4.01. Is it okay? And now when you multiply this, you get 20.05 meters per second. So that becomes the velocity at t equals to 2, right? So basically x is for t, right? T equals to 2 seconds, and we get instantaneous velocity accurate to 2 decimal places, right? Which you could approximately write as 20 meters per second. If I do not say 2 meters per second, we can assume h as 0, right? Assuming h as 0, it gives me 20 meters per second. I hope that gives you a good connection between average rate of change and instantaneous rate of change. In this playlist, which you can search by Anil Kumar rate of change playlist, you'll get many examples in which we'll discuss average rate of change and instantaneous rate of change, and we'll discuss this method in great details, which is called difference quotient, right? Let me write down here, difference quotient. I'm Anil Kumar, and I hope that helps. Feel free to share my videos with your friends, write your comments, and if you like, I'll greatly appreciate it. Thank you, and all the best.